Have you ever wondered how your email inbox just knows what's junk? Or how a bank can approve a loan in minutes? Well, that's the magic we're diving into today. We're talking about classification, one of the most important jobs in all of artificial intelligence. And by the end of this, you'll see exactly how it all works. It all starts with a question that, let's be honest, we've all asked. You open your email and somehow all the junk mail is already neatly tucked away. It feels like magic, right? But it's not. It is a perfect everyday example of classification in action, and we're about to pull back the curtain. So before we go all in on classification, we kind of need to understand the neighborhood it lives in. Think of machine learning as this amazing toolkit with 4 primary tools, and each one is built for a very specific kind of job. Let's do a quick meet and greet with the whole family so we can really see what makes classification so special. First up, you've got prediction. You'll also hear this called regression. This is basically the fortune teller of machine learning. Its whole purpose is to predict a number on a sliding scale. What's a stock going to be worth next month? What's the temperature going to be tomorrow? If the answer is a specific number, it's probably a prediction task. And that brings us to our star for today, classification. This is the great sorter. Now, instead of predicting a number, its job is to put something into a group or a class. Is this email spam or not spam? Is this credit card purchase legit or is it fraud? See, the answer is a label, not a number. Third on our list is clustering, the organizer. And here's the really cool twist. With clustering, we don't give the AI the answers beforehand. We just dump a whole mess of data in front of it and say, hey, find the natural groups here. It's like giving someone a giant bag of Legos and telling them to sort them, but without telling them what shapes or colors even exist. And finally, we have association. This is the pattern finder. It's designed to find hidden relationships in massive data sets. And the classic example you always hear is the supermarket that discovered that customers who buy diapers late at night are also weirdly likely to grab a 6-pack of beer. Discovering that little pattern helps them rethink how they lay out their stores. All right, so now that we've met the whole crew, let's zoom in on our main topic. We know it's about sorting stuff, but let's get a little more specific about what's really going on under the hood. Okay, so at its core, classification is what we call a supervised learning task. Now, don't get hung up on the term. We'll break it down in just a second. The goal is pretty straightforward. We're trying to build a system that takes some kind of input, like an email, and assigns it to a predefined category, like spam or not spam. The key thing here is that the output is always a distinct label from a set list. So the big question is, how does a machine actually learn to tell the difference? I mean, it doesn't have intuition or experience, right? It has to be taught. And the way it learns is actually pretty fascinating. Right, that term from before, supervised learning. This is the secret sauce. And honestly, it's just like teaching a toddler with flashcards. You show the machine a picture of a cat and you say, cat. You show it a dog, you say, dog. You just do this thousands or even millions of times. You are supervising its learning by giving it the correct answers over and over again. This whole process really breaks down into 3 simple steps. First, we feed the machine a mountain of labeled examples, a million emails that a human has already marked as spam or not spam. Second, the model churns through all that data and starts to build its own internal logic. It starts to notice patterns, like emails with free money are probably spam. Finally, once it's trained, you can show it a brand new email it's never seen before, and it will use that logic to predict which category it belongs in. Now, I know this can all sound a bit abstract and techy, but the truth is classification models are working for you behind the scenes all day, every day. Let's look at a couple of huge examples. We started here, and it really is the perfect example. Every single time an email hits your inbox, a classification model instantly scans it. It looks at the words, the sender, all kinds of things, and then slaps a label on it. Inbox or spam. That one little application saves us all a ridiculous amount of time. And here's another one with a massive real-world impact. When you apply for a loan, a bank uses a classification model. It looks at your entire financial history to classify you into a risk category, like low risk or high risk. And that simple classification is what determines whether or not you get that loan. Now, just like a carpenter has more than just a hammer, a data scientist has a whole toolkit of different classification algorithms. We're not going to get buried in the math, but it's good to know the names of a few of the key players. You'll hear these names a lot if you hang around in machine learning. Each one is just a different strategy for sorting data. You can think of logistic regression as trying to draw a straight line to separate 2 groups. A decision tree is more like a flowchart, and a random forest? That's like getting a whole committee of decision trees together and having them vote on the answer. Different paths, same goal. A decision tree is probably the most intuitive one. It really works just like a game of 20 questions. It asks a series of simple yes or no questions to narrow down the possibilities. For an email, it might ask, does the subject have a dollar sign? Yes? Go this way. No? Go that way. Does the sender have a weird address? It keeps branching down until it lands on a final answer. Spam or inbox? We're almost done, but I really want to hammer home the single most important distinction to remember about all of this. This is the bright line that separates classification from its very close cousin. Okay, time for a pop quiz. Let's say we're building a model to predict the exact selling price of a house, down to the dollar, like $542,300. Is that a classification task? The answer is a definite nope. And this is the critical takeaway. Because the price is a continuous number, it could be anything on a scale, it is not classification. That's a job for regression, the thing we called prediction at the very beginning. Remember, classification is for sorting things into a few fixed boxes, not predicting a precise number. This table sums it all up perfectly. Just look at the differences. The output for classification is a category, a label. For regression, it's a number. Their goals are different too. Classification is trying to draw a line between the groups to separate them. Regression is trying to draw a line that runs through the data points to predict where the next one will be. So, if you remember just one thing from this whole explainer, let it be this. Classification predicts a category. Regression predicts a number. It's that simple. Here's a really simple analogy to lock it in. Imagine you're at a shipping depot. Classification is the job of looking at the label and putting a package on the right truck. Truck A, Truck B, or Truck C. Regression is the job of putting one of those packages on a scale and telling you it weighs exactly 15.7 pounds. So we've seen how powerful classification is. It's already protecting our inboxes, shaping our finances, and so much more. It's a fundamental tool for bringing order to a chaotic, data-filled world. Which leaves us with a final question. Knowing how good it is at sorting things out, what other huge, messy problems should we be asking AI to classify for us next?